Real events told with respect. Pressure found 9 ways out. Best Friend of Charleston. On Christmas Day, 1830, this tiny locomotive began carrying paying passengers on a 6-mile route out of Charleston. It was widely regarded as the first locomotive built entirely in the United States for regular passenger service. Its upright boiler made steam in a machine so new that the operating rules were still being invented. A safety valve at the top was supposed to hiss whenever pressure climbed too high. The noise was not a fault, it was the warning working. On June 17, 1831, according to later accounts, the fireman grew tired of that hissing. He held the valve shut. With the steam trapped, the boiler pressure rose beyond what the shell could contain. The boiler burst. The fireman was killed, the locomotive was destroyed, and the engineer survived. Best Friend became the first locomotive boiler explosion recorded in the United States, only about 6 months after its celebrated first run. Salvageable parts became another engine called Phoenix. The railroad changed its rules, so the engineer stayed at the controls, and for a time, it placed a flat car loaded with cotton bales between the locomotive and its passengers. The machine had done exactly what its warning predicted. Silence was the dangerous setting. Moselle, built in Cincinnati and finished in March 1838, she was one of the fastest riverboats in America. Her celebrated Cincinnati to St. Louis run took 2 days and 16 hours. On April 25th, an estimated 280 to 300 passengers crowded aboard. Moselle stopped just east of Cincinnati to collect more travelers, but Captain Isaac Perrin wanted the riverbank crowd to see what his famous boat could do. The 4 boilers stayed at full steam while the boat sat at the landing. Witnesses reported unusually high pressure, and at least one anxious traveler got off. Then Moselle pushed away from shore. All 4 boilers failed almost together. The bow disintegrated, iron and timber crossed the river, and the surviving stern drifted roughly 100 yards before sinking. The blast killed about 160 people. Congress had already been debating exploding steamboats. Later that year, the first federal steamboat safety law required inspections, but it was weak and hard to enforce. The race for speed was still stronger than the rule meant to restrain it. Moselle proved that pressure held for performance could turn an idle boat into a bomb. Lucy Walker, a 144-foot side-wheeler built only the year before with a 24-foot beam and 3 boilers. The surviving engraving shows the instant the upper works broke apart. The boat belonged to Cherokee businessman Joseph Van. Its crew included enslaved black workers, and its passengers represented the moving frontier. Lucy Walker left Louisville at noon for New Orleans, then stopped at New Albany for more passengers. At about 5 that afternoon, the engine stopped several miles below town while repairs were attempted. The precise cause remains uncertain. Contemporary reports blamed everything from low water and a faulty pump to reckless racing, but the evidence never settled one clean answer. Then all 3 boilers exploded. The boat caught fire and sank in about 12 feet of water. Passenger and crew lists went down with it, so the toll varies sharply across reports. The historical account says more than 100 people may have died. That uncertainty matters. Early steam travel could lose the machine, the witnesses, and even the list of people aboard in the same instant. Public anger kept building until the Stronger Steamboat Act of 1852. That law brought hydrostatic boiler tests, maximum working pressures, boilerplate inspection, and licensed engineers. It was written because the first law had not been enough. Sultana, 260 feet long, built for 376 passengers and a crew of 85. On her final voyage, 2,127 people were aboard. Most were Union soldiers finally going home after surviving Confederate prison camps. The Civil War was ending, and the government paid steamboat captains per soldier carried. Overcrowding was not an accident hidden from view. It covered every deck. One of Sultana's 4 tubular boilers had already sprung a leak. A mechanic wanted to cut out the damaged seam, a repair that would take 2 or 3 days. Instead, a thinner patch was riveted over the bulge in about 1 day so the boat would not lose its paying passengers. The boilers were difficult to clean with muddy Mississippi water. As the overloaded, top-heavy boat turned through the river, it rolled from side to side. Water shifted between connected boilers, exposing hot metal and then washing back across it. At about 2 in the morning, 7 miles north of Memphis, 1 boiler burst and 2 followed almost instantly. The blast tore upward through the packed decks. The wooden vessel then burned and drifted without a pilot. The most recent historical count places the dead at 1,164. The exact number has varied for more than a century, but Sultana remains the deadliest maritime disaster in United States history. No one was ultimately held accountable. The patch mattered, the sediment mattered, the rolling mattered. So did loading more than 5 times the passenger capacity onto one fragile machine. Westfield. On Sunday, July 30th, 1871, the Staten Island Ferry sat in its slip at Manhattan's Whitehall Terminal. Families and day trippers filled the decks while the ferry prepared to cross New York Harbor. Below them was an old boiler. The later investigation examined a worn pressure vessel, a faulty gauge, and a safety valve described as being in terrible condition. The precise immediate cause remained disputed, but the protective instruments could not be trusted. The boiler exploded before the ferry left the dock. The forward deck opened under the waiting crowd. Pieces of the boat and terminal became debris, while survivors and rescuers were thrown into the water beside the slip. 85 people were killed and hundreds were injured. The recovery continued around the pilings where the ferry had been waiting. The Railway and Ferry Company entered receivership the next year. Its president, Jacob Vanderbilt, was arrested but not charged. Westfield joined the growing evidence that inspection on paper meant little if gauges, valves, and old boiler plates could still pass into service. The ferry never reached open water. Pressure had found the passengers while the boat was still tied to shore. HMS Thunderer, a 9,330-ton ironclad, about 307 feet long, built for a crew of 358. In July 1876, she left Portsmouth for a full-power machinery trial. The ship carried 4 box boilers. In one of them, the pressure gauge was broken and the safety valve had corroded in place. When the steam stop valve to the engines closed, pressure continued rising inside a boiler with no working route of escape. 1 box boiler burst. 15 people died immediately, including the commanding officer, and about 70 were injured. 30 more later died from their burns, bringing the toll to 45. It was the Royal Navy's deadliest boiler explosion of the 19th century. The failed boiler was studied in detail, and a model of it was preserved by the Science Museum. Thunderer was repaired, completed, and eventually entered service. But the trial had exposed a chain in which every protection could be defeated at once. The gauge could not tell the truth, the valve could not move, and the stop valve trapped the result. The boiler did not need high modern pressure to kill. Redundancy fails when protective paths go untested. Grover Shoe Factory, Brockton, Massachusetts, 1905. The 4-story wooden factory made Emerson shoes and employed hundreds. Steam heat came from 2 coal-fired boilers in a brick boiler house attached to the building. The older backup boiler was 17 feet long and 6 feet across. It had been built in 1890 and was seldom used because the chief engineer did not trust it. That Monday, the newer boiler was being cleaned, so the old one carried the factory. At 7:45 in the morning, a manager called about strange noises in the radiators. Minutes later, the old boiler split and rocketed through 3 floors and the roof. The boiler tore free of the factory. The flying boiler knocked over a water tower. The tank fell through the factory, floors collapsed, and burning coal ignited the wreckage. Broken gas lines and nearby barrels of naphtha fed a fire that reached workers trapped beneath machinery. 58 people died and 150 were injured. Investigators found a crack in a riveted lap seam. The defect had escaped an inspection only months earlier, and no criminal charges were filed. The disaster helped force Massachusetts to act. A state board of boiler rules followed, then a 1907 inspection law. The pressure for common rules helped lead toward the National ASME Boiler and Pressure Vessel Code. The hidden crack was real, but so was the system around it. Grover turned a private failure into a public code. USS Bennington, a 244-foot steel gunboat, displacing 1,710 long tons with 4 coal-fired boilers. On the morning of July 21st, the crew had finished coaling in San Diego and was preparing to tow another Navy ship. Many sailors were below decks washing coal dust away. At about 10:30, one boiler went beyond its safe pressure. The investigation found 3 problems working together: oily feed water, an improperly closed steam valve, and a faulty gauge. The boiler ruptured into spaces crowded with men. Steam swept through the living compartments. The blast opened the hull to the sea, and Bennington began listing to starboard. A tug called Santa Fe grabbed the gunboat and beached it before it could sink. 1 officer and 65 enlisted men died. Nearly every one of the 46 survivors was injured, and 11 later received the Medal of Honor for extraordinary heroism in the aftermath. The Navy inquiry did not blame the engineering crew. The ship was too badly damaged to repair and was decommissioned that October. A warship built to survive enemy fire had been opened from the inside by its own power plant. The gauge, valve, and feed water were separate faults. Systems fail through combinations. Boston Molasses tank. This was not a steam boiler. It was a 50-foot tall, 90-foot wide pressure vessel holding 2.3 million gallons of molasses. The engineering lesson was the same. Stored pressure needs a shell strong enough to contain it. The tank may have leaked from its first filling in 1915. Residents collected the drips, while the company painted the steel brown to hide them. The tank was never properly filled with water for a full leak test, and the executive overseeing construction had no engineering experience. On January 15th, Boston warmed rapidly after bitter cold. A fresh warm load had arrived the day before. Fermentation may have added carbon dioxide pressure, while repeated filling had cycled stress through thin steel and weak rivet holes. At about 12:30, the cylinder tore open. 12,000 tons of molasses rushed into the north end. The wave was estimated at 35 miles per hour, fast enough to break buildings and buckle the elevated railway. 21 people died and 150 were injured. In the wreckage, pieces of the tank lay folded beneath the structure they had struck. The company blamed sabotage. The court listened to years of engineering evidence instead. Modern analysis found the steel roughly half as thick as it should have been even by the standards of the time. The material was brittle and flawed rivets concentrated cracks. After a long civil case, the owner paid damages. Boston tightened the rules around large structures, requiring licensed professionals to sign plans and supervise construction. The age of an unqualified manager ordering a giant tank into existence was ending. 9 machines, a silenced valve, 4 racing boilers, an uncertain river wreck, an overloaded troopship, a ferry still tied to shore, a corroded naval valve, a hidden factory crack, 3 faults inside a gunboat, and a tank built without enough steel. The shapes changed, the lesson did not. For the next failure mode, subscribe.